In this lecture we're going to go over section 2.2, everyday consumer products, and we're going to consider three new homologous series: alcohols, carboxylic acids and esters. All members of the alcohols contain the functional group hydroxyl. So that's the main thing that makes them stand out, the presence of this hydroxyl functional group. So here's the simplest alcohol you can get with just one carbon, and this is a hydroxyl functional group, the OH. This is the exact same molecule, okay, and it's perfectly acceptable to draw the OH like this or this, so you don't need to show the bond between the oxygen and the hydrogen. As I said, this is the simplest alcohol. It contains one carbon, so the name is derived from methane. You drop the E and add on an OL. So these are structural formula of methanol. If you have two carbons, you have ethanol. If you have three carbons, you have propanol. But once you get to three carbons, you have to say where the OH group is, because you have a choice to either have it at the end or have it in the middle. So here's two different forms of butanol. In the top example, the OH group is on the end carbon, whereas in the bottom example the OH group is on this carbon. So the first one would be butan 1-ol, because the OH is on the first carbon. We number from this end, not from this end. You always try to get the number as small as you can get. And this one, the OH is on not the first but the second carbon, so this is butan 2-ol. So once you get past ethanol, you have to say where the OH group is. Only methanol and ethanol is it not required. Propanol, butanol and so on, you must say, do you have butan 1-ol or butan 2-ol or whatever. Note when you're using the OH as opposed to showing the O bond H, the bond from the carbon to the OH group must point at the oxygen, not point in the middle or point at the H. The bond is from the carbon to the oxygen, so just make sure you do that when you draw out structures. Okay, what do we use alcohols for? Well, the biggest single use is in the food and drink industry, but it's also widely used as a solvent. It will dissolve lots of things which are not soluble in water. So for example, here I've got National 5 Chemistry written in a permanent marker. Now when you talk about pen markers being permanent, you just mean they're not soluble in water. So if I try to wash this off with water, it shouldn't be removed. So I'll just put some water on a cloth here and try and rub it off. So it's not soluble in water. However, it is soluble in alcohol. So if I get a cloth and dip it in alcohol, I should be able to remove this. I've got some ethanol here. And hopefully this will be removed by the ethanol. So that's just one example of ethanol being used as a solvent. Other major use of alcohols is as a fuel, because they burn very easily and are great fuels. Okay, so this is just a quick demo to remind you how flammable alcohols are, which means you have to be very careful when you're heating them up. but on the other hand it makes them very useful as fuels. So I've just put a little bit of alcohol on the table, and then we can see how easily it burns. And of course this can be put to more useful things, for maybe perhaps an alternative fuel for cars instead of petrol, or you can just burn it for the fun. Okay, so we know what alcohols look like. We know they contain the hydroxyl functional group. We can name them and we can give uses of the alcohols. Let's move on now to carboxylic acids. And carboxylic acids, they all contain the carboxyl functional group. So here's the first two carboxylic acids. 1 carbon, methanoic acid. 2 carbons, ethanoic acid. The carboxyl functional group is the C double bond O OH. C double bond O OH. And if you write it as a shortened structural formula, it looks like that. COOH. That's your carboxyl functional group. Now, once you get up to 3 carbons in the alcohols, you had to start saying where the carboxyl group was. But carboxylic acids always have the carboxyl group on the end carbon, so you never have to put a number in to say where the carboxyl group is. So 3 carbons, propanoic acid, then you get butanoic acid, pentanoic acid, hexanoic acid, etc. You do not need to say where the carboxyl group is, it's always on the end carbon. Right, uses of carboxylic acids include ethanoic acid. Dilute concentrations of ethanoic acid are used as vinegar, which prevents bacterial growth. So it's used in the food industry to preserve foods, you know, things like pickles and chutneys. It's used as a feedstock for the plastic industry. That means it's a reactant to make plastics. And if you've done Unit 3, you'll remember that you use carboxylic acids to make condensation polymers. So here's a carboxylic acid. It's a special carboxylic acid called a diacid because it's got 2 carboxyl groups, and it reacts with a alcohol containing 2 OH groups to produce this condensation polymer. So this is a very big use for carboxylic acids. And it's also used as a household cleaner, particularly useful in areas of hard water where limescale builds up. Now, limescale is basically just a metal carbonate, and metal carbonates react with acids, so we can clean the kettle or whatever it is with a carboxylic acid. Okay, finally, esters. Now, esters contain an ester group. Here are some examples of esters. Now, you would not be required to know how to name these esters. This one's methyl propanoate, this is ethyl ethanoate, this is butyl methanoate. What you would be expected to do is, given the name methyl propanoate, you should be able to recognise that that is an ester. The ester group is the C double bond O, okay, which they all have. And you should know how esters are made. You make an ester by reacting together the 2 previous homologous groups we've talked about, an alcohol and a carboxylic acid. They react together to give you an ester. Now, esters are very useful compounds. They're widely used in the manufacture of perfumes. They tend to be very pleasant smelling compounds. Related to this is the use as a flavouring. Again, nice smell, nice taste, and they're added to a lot of foodstuffs. and like alcohols, they're also used as industrial solvents. So they're the three main homologous series that we're interested in section 2.2: alcohols, carboxylic acids, esters. Make sure you don't get them confused. So what should you be able to do? You should be able to recognise and name members of the alcohols with up to 8 carbons. Okay, so you don't need to go beyond 8 carbons. You should be able to recognise and name members of the carboxylic acids with up to 8 carbon atoms. You should be able to recognise esters from their name or structure and know how they are made. You should be able to recognise the hydroxyl group, the carboxyl group and an ester group. And you should know some uses of the alcohols, the carboxylic acids and the esters.